Hello, this is exercise 10F. We've previously looked at a variety of trigonometric equations, and I'm going to lead on from that. Of course, I gave some homework help as well, but this is definitely a step up from that. These are more complicated equations. So what do I mean by solving transformed trigonometric equations? And I suppose one thing, let me just point out, there is a retrieval starter here that Miss has been putting on a few of these. You're meant to learn them. The one thing I was going to say is by transformed is we do something to the x. You may remember we drew some graphs in the past. I've asked you to draw things like y equals, I'm trying to think, well, if I from GCSE you would have seen transformations of this sort, I would have thought, y equals sine of 2x. And we've said whenever it's in the brackets, well, it's a time, so you kind of think it's a stretch, but because it's in brackets, it's a stretch in the x direction, and it's a stretch by a scale factor of 1/2. And we talked about all those transformations, and so what we're looking at today is we're going to do something to the x in the bracket, which will change the trigonometric equation. So that's what I mean by transformed trigonometric equations. These equations here, by the way, these should be fairly straightforward. Obviously, you move the sine over here, you divide by 3, then you move the cos over. I'll just show you this one. This one is potentially the hardest one for you. So we start off, we've got tan squared x, of course we know that means tan x all squared. So the first thing I've got to do is move the squared on the other side, it becomes a square root. So it's square root of 1.5. And I'll just show you this because it's easy to go wrong. So if I do that on my calculator, I go 1.5 and I want the square root of that. And I get root 6 over 2. There you go. It's not a number I would have imagined, but I could do it as a decimal. It might be, it's not as accurate, but you kind of get a feel for it. It's 1.22. And therefore x, notice I haven't solved this yet, x is the inverse tan of the 1.22. And it all looks fairly straightforward, as long as I suppose you decide to move the square root over to the other side as the square root first, then you're going to get these right. Well, at least that's how it seems. I don't think that's 50.8. I don't think that's the only answer, and that's because when you square root something, you can get more answers. So you could, for instance, get an answer of minus square root of 1.5. Which is, I'm just going to write or, equals minus 1.22. Now, bear in mind that when you add 180 onto this, and you will hopefully remember that with theta and tans, when you play around with that tan theta to get from theta, your principal solution, your first solution, to your second solution, you just go theta plus 180 and 180 on. So that's why I'm adding 180 on, which is obviously 230.8. So we've got two solutions here, but over here, because square rooting can be a plus or a minus, we've potentially got more solutions, and I don't know what's going to happen here. So I do the inverse tan. So the inverse tan of minus 1.22. I now get minus, and this is important, minus 50.8, assuming I've done it correctly. Now, on the face of it, who cares, because it's not in the interval. But remember, you can just always add on 180, to, a little bit like we did here, add on 180 to get our next solution. So if I add a 180 on, I get 129. So this is an extra solution, 0.3. And is that 3? Yeah, it sounds right. I'm not sure if that was meant to be 0.7 before, but you get the idea. And of course, you can always say, well, effectively add 360 on, or just add another 180 onto here as well. For a fourth solution, so if I do that, I end up with 309.3. Now, potentially then, there are 4 solutions on this one question. It looks quite enough. Yeah, there were 4 solutions, you see. So just be aware, I've got the answers on there, and obviously it's a bit messy. Hopefully you can see it. But that's something for you to bear in mind. There are 4 solutions to those ones. If I just go on, reminder of those three rules then, sine, cos and tan. It says them there, we're going to use them, we've already used one of them already. And don't forget we can always add 360 on. So these are the transformed equations. So up till now I haven't actually looked at a transformed equation, but it's this bit here, the 2 theta, that makes this different. So I'm going to try and solve this. I'm going to write it out. Sine 2 theta equals 0.5. And I do it exactly the same way. I go 2 theta equals, notice 2 theta equals the inverse sine of 0.5. And if I do that, the inverse sine of 0.5 should be 30 degrees. Yes, it is. So 2 theta equals 30 degrees. Now the temptation is now to move the 2 over, theta equals 15. It's wrong if you do that. Well, it's not wrong, but you miss solutions, because when you inverse sine, using our sine trick of 180 minus sine, so remember this, so with sine you get your theta, and you do 180 minus it. So here, if I do it now, I get 150. And it's important you do it now, before you move the 2. So now theta divides both of them by 2. I get 15 degrees, and I get 100 and, about taking it away, 75 degrees. I need to be slightly careful, by the way, that I've done enough solutions. So because it's theta is between minus 180 and 180, sine of 2 theta, well, technically I have to go minus 360 is less than or equal to 2 theta is less than or equal to 360. Notice what I've done, because it's 2 theta, I've had to double both of these numbers. Now that basically tells me that even though I found the one extra solution, there might not be enough. I might still need to find more. So remember the trick: to get more solutions you add 360 on, or you can take 360 away. Now let's see what I'm going to do. If I add 360 onto that, I get 390. That goes past that. And if I add 360 onto that, I definitely go past 360. But I can take 360 off. 30 minus 360 is minus 330. And you notice I can have negatives here. And 150 minus 360, remember I'm taking 360 off, is minus 210. So when I divide by 2, I did remember to do this one, I remember to do this one, but I've got to do these two as well. So this gives me minus 165. When I divide this by 2, and minus 105. And those 4 solutions are all now back within the right interval. So what did I do? That's the graph. You basically are meant to effectively think of it like that, and within the interval, let's, from there, 180 to 180, you get 1, 2, 3, 4 solutions. There they are. And there's the same answers as I got. So here's the second question. I've got, now let me just start off with this scenario. So let's get into good habits. It says theta is between 0 and 180. I've got 3 theta. So really I should be saying 3 theta belongs to the interval. And I times both of these numbers by 3. I get 0 and I get 540. So that tells me I've got to go and look for an answer between these two numbers. Okay, let's go and look for them. So I've got tan 3 theta equals 1. There's no number at the front, no squared, no funny goings on, so I can just go 3 theta is the inverse tan of 1. And if you do that in your calculator, you get 45 degrees. Now, be careful, we now look immediately for the extra solutions. And I've already told you that for tan theta, you get your theta, and then to get your next one, you do theta plus 180. So I add 180 on, I get 225. Have I got to the end of my, no I haven't yet. I was going to say, have I got to the end of my limit? No, I keep going until I get to 540. So I can always just add another 180 on with tan. Tan's great. It's really the equivalent of adding 360 onto this. But with tan, just keep on adding 180 on, and you're allowed to do that. 405, there you go. Add another 180 on, will give me another solution. But if I do that, it'll get me past the 540. So that's actually it. So that's 3 theta is all of these. Therefore, theta is 15 when I divide the 45 by 3. Divide the 225 by 3. That sounds like 75. Hopefully I'm getting my maths right here. And that sounds like 135. Again, I hope I've got my maths right. Otherwise, I'm going to have to, yeah, got it right. 1575, 135. So, relatively straightforward. Third example of a transformed equation. I quite like these, to be honest. Well, first of all, again, let's just look. It says theta plus 20 here. So I changed my interval. This is written in as, inequalities, but you get the idea. I add 20 onto that because it says add 20 on it here. So there you go, 20. And 360, add 20 on, that's 380. So it tells me to look between these two numbers, 20 and 380. Okay, I'll do that then. So sine of theta plus 20 equals 0.4. And you'll notice it doesn't say anything 5 or plus 6 outside the bracket. So the first thing I'm going to move is the sine. That will leave theta plus 20 over here. That's the inverse sine of 0.4. And I have no idea what that is. So inverse sine of 0.4. It tells me to give my answer to 2 decimal places. So I suppose I should bear that in mind. It says 23.58. I'm not dividing, so I don't need any more decimal places. But note, they're done. Mistake there. That's theta plus 20. Let's write that. Make it look as like I had it like it all the time. That's a 0 on this. But of course now theta moves to be on its own. The 20 moves over. That becomes a minus when I move it over, and I think that's just 3.58 degrees. Have I made a mistake? Yes, I have, because I didn't include any other answers. So really, even before I do this move the 20 over, and this is where everyone always goes wrong. They always do that. I look for more answers. So of course this is a sine question, and sine, when you get your theta, you then do 180 minus the theta. So 180 minus the 23, 180 minus 23.58. And I've got 156.42, so that's a solution. 156.42. Notice, by the way, that, these numbers are meant to be in between 20 and 380, and these both are. And once you get one solution, you can add 360 on. I reckon if I add 360 on, I'll get 383, which is marginally too much. So that's the end of my solutions. I've got these two. Don't forget to take away 20 off both of them. I already have for this one. 136.42. Let's see what my answers were. That looks about right then. And I've got a couple of seconds to just do this last one. So first of all, notice it's x over 2. So really I should be saying x over 2 belongs to, and because it's divided by 2, I divide both these numbers by 2. I've got to look between 0 and 360. Okay, fair enough. So I'm going to move the cos onto the other side, and that becomes x over 2 is the inverse cos of minus 0.4. I'll do that quickly. Inverse cos of minus 0.4. And I get 113.58. I've given it one extra decimal place just in case, because I want one decimal place here, so I've given it 2. I'm going to multiply by 2, and that's the reason. But before I do that, of course, I just want to get into good habits, get you into good habits. Always think to yourself, is there any more solutions? It's a cos question. The cos is, I know there's one answer, and then to get the other answer, I do 360 minus it. So here I do 360 minus that answer, and I get 246.42. This is x over 2, so I can times both of those numbers by 2. This one's on my screen already, so I'll just do that one. 492. It says to one decimal place, 492.8. This one sounds like 227 point something or other. 227.1 if you do it accurately. There you go, and then we're done. And your job, of course, is to have a look at exercise 10F. There's some questions there. There's an exercise 10G coming up, and look out for homeworks on Moodle. I think the next homework coming up, I can't remember what it is now, but I'll make sure it's on Moodle for you. So best of luck, and hope that goes okay.